Hi, I'm Yanni of 4M Australia. This is a full instructional video of 4M's new software package, FINE4Rate. FINE4Rate is a full 3D BIM CAD software dedicated to draw and export the 3D model of a building with all the necessary information to populate the data fields of the accurate sustainability software for a single or multiple dwellings of a given building. As you can already see in your screen, FINE4Rate uses a familiar CAD environment with a CAD-like menus and commands. It also uses as its file format the native DWG type. For our instruction purposes, we're gonna use a two-story, two-dwelling project. This is the ground floor and this is the first floor. But let's get started. There are 9 steps that we'll follow before we select the final command from the accurate sustainability software to run the simulation of a dwelling. Step 1. Creating a new project. We're going to use the command new project, and we're going to go to the directory or folder that we'd like and type the name of our project, say for this example demo01, and save. What the software really does, it creates the project folder demo01.bld under the main project folder, and also it creates the DWG file, the demo01.dwg file, that is the file of our current project. Next, we define the project info. Give a project name, say demo01, project code, define the building class and the dwelling type, assessment date, and assessment time. And then we can either write down all the dwelling details info or take them from the accurate library. Same for assessor details, client details, and plan document details. All right, save. Step 2, define constructions. Under the Auto BLD constructions, we can define openings. As you can see, they're already populated and we can use these. However, we could change, for example, this one from the library, and these are the actual libraries of Accurate. And you can see the details and the analysis here. For external walls, same applies, cavity brick, brick veneer, frame wall, for example. Internal walls, brick, plaster, or partition wall, or again I can choose from the Accurate library the ones I like. Floor ceilings. I'm gonna use the concrete slab bare to bare, the ceramic tiles to bare, carpet bare, ceramic tiles gap plasterboard, carpeter plasterboard. Okay. And about the roofs, I have a concrete with pebbles plasterboard, and this is the one I'm gonna use also. Step 3. Define the building levels and draw the building shell in terms of walls and openings. I have two options. First, I could have the IFC 3D model of the building from the architect, which saves time and effort, or I could have the 2D plan drawings that I'm going to use as XREFs. Either way, I have to copy the architect's files to my working folder. So, for our example, it's the ground floor, first floor, or the ARC IFC. And I'm going to use the first option, that is file import IFC file. I'm going to check the ARC IFC file. I'm going to use that. Import the building elements. And as you can see, I have the 3D model of my building. And if I'll go to auto build the building definition, then I'm going to see that I have my two levels there. And what I have to do now is just define the actual construction of my walls. For example, auto build the wall multiple modification. These walls are of the cavity brick type. The internal walls are of the brick wet plaster type. My window is W1 and it's a sliding window with 45% opening and with Holland-Brine and insect screens, and its type from the library is the B type, which is sliding type. And I have to do that for the whole lot. If we don't have the IFC file, but have the 2D DWG files, things are a bit more complicated. I first have to define my building in terms of levels. So for the first level, which has an elevation of 0.1 meters, and here I have to say that we are working in meters, so if our DWGs are in millimeters, we just have to scale them by a scale factor of 0.001, and the file is the ground floor and new, and my second level will be 3 meters higher than the ground floor, which is 3.1, and my X-ray file will be the first floor. Okay, and by clicking plan view, I just zoom extend my drawing, and I'm using the explore layers to just lock my two XREF layers so I won't accidentally delete them. Right, so what I have to do now is just draw my walls, external walls, internal walls, and openings. to reach the same state that I have if I had the IFC file instead. But this is actually a very easy procedure. I could use a simple rectangle command, and then I could use the external wall from polyline command, and the type of the wall is cavity brick with 0 elevation, 2.8 height, and a thickness of 0.2. And here I could use, if I had a double wall, I could use the wall above feature. So by clicking accept and selecting the polyline, I just enter the sign point and right click, and as you can see, I already have the external wall, right? I can do the same for internal wall. The type is brick, the height is 2.8, and the thickness is 0.1 meters. So it's from here to there. That's one wall, and as you can see, same definition here to there. And that's the result, right? And now let's put the doors, which is 2.1 height, and let's see, it's 0.8 length. I don't have to do anything else. I don't want to have a label, because for the internal doors, just have one door here and another door there. But for my external door, I have to check the type. I want to label it. I want to give a name, D11, first unit, number 1 door, and clicking accept. From here to there, and opening side there, and our label here. Next, for my window, I have a type B, clear window, which is at a height of 2.1, 0, and 1.5 in length. It's W11. It is a sliding window with openable of 45%. Column blinds, insect screens, yes. Select the wall from here to there. Next window. It has a height of 1.2 and a rise of 0.9 and a length of 1.1. Its name is W12. Again, let's say it's a sliding window. Same applies. So from here to there. Say we have an awning window, A type, same dimensions, and is 13, the awning window, 90%. Open it. From here to there. And I have the same window for the bath. Same applies, just the name is different. Made a mistake. It's 1 meter, say, and it's not an awning, it's a louver. So what I can do, I just double click it and louver length 1. That's the louver window. Ask me to do which length is wrong. I say this one, and now I've got this. And that concludes the ground floor. Can do that preview. And to you. Since first floor is similar to ground floor, what we could do is copy the ground floor to first floor by using the command to the BLD copy building floor. I'm gonna check the all external walls, but not the internal walls, and copy them to the second level. Right. What I could do now is just stretch this wall to there. All right. And actually I can copy this window to there and draw internal wall, same on here, there, another one here, there, and another one here. And then place the doors. And also I can draw an opening, and that will be defined as a permanent opening. Height is 2.1, rise 0, and length 0.8. Label from here to there. And of course, this window has to be named differently and save. And here I have axonometric view, and also I have a layer management tool, which is really very convenient. And I could freeze the X-ray and the 3D, and I could hide and see my building. Step 4. Definition of dwellings and zones. Auto build the element parameters dwellings. We have the dwelling definition dialog box. We define the number of dwellings, in our example 2. Dwelling name U1, unit 1, footprint height 5 meters and width 10 meters. and this will gonna populate the ventilation page in accurate sustainability software. And second dwelling, unit 2, footprint height 5 meters and width 11 meters. And then auto build the element parameters zone. We have a total of 3 plus 4 equals 7 zones in our building. My first zone is 1 KLD, and it is living kitchen type. And here I can define the specific density of lights in the zone, the downlight type, and if it's here or not, the exhaust fan, the ceiling fan. A vertical offset if the wall is above the level elevation. Second, 1 bedroom. Bedroom, 1 bath. It's in a conditioned space, and we have an exhaust fan there. 2 KLD. Two bed, two bath, and this is an unconditional space. It has an exhaust fan and 2 weir, which is a nighttime space without an exhaust fan. Great. Let's go to ground floor, and by using the dwelling definition, I can select the entities without the inner walls, and I can choose the U1. Same for second floor, first floor rather. Second level it was unit 2. Back to my ground floor. Let's save it. And by using the zone definition by point command, I click inside the zone, a direction, and I choose KLD, the same head. But let's go one floor above. To KLD. Bed. Path. Weir. And save. Now that I have defined these, I can use the layer management tool and just freeze them. So I will not accidentally delete them. Step 5. Define the north orientation by using the auto build the north direction icon, and I can either write the orientation or just point to it, or just leave it as it is in 0 degrees, and that in the ventilation page of accurate sustainability software, this wall will be in the 0 orientation, and usually that's what I'll do. And before finalizing a running simulation, I just change the orientation in the accurate sustainability software. 6. Define floor ceilings and roofs. Let's zoom here. Let's go to first floor, and by clicking the icon floor ceiling, the dialog box appears, and I'm gonna define a floor to ground of type ceramic tiles bare for bathroom. I don't want to be hatched. And another one, but of a different type, carpet bare for the rest of my zones. As you can see here, I don't have to separate in different zones, but just apply it to the whole area. I don't need to define a roof here or a ceiling, because I'm going to define the floor on the above floor. But if I had the roof, I had to define it here. So again, let's have a floor to internal space of type ceramic tiles air gap plasterboard, and have that for bath. Right now, as you can see, this extends from the ground floor. So here, actually, I have a floor to outside air. So what I could do is just from my layers, just to thaw the first XRF as well. So here I can see I can just have a rectangle from here to there. Okay, and this actually is my floor to outside air, and this is floor to outside air, which is of the carpet air gap plasterboard type, and I accept it, and I can select by pressing S the polyline, and yes, I have that type there, and the rest of it is floor to internal space type F5, and up to there. Right, and then I have to freeze again. Okay, and let's have also a roof. I could have a simple concrete roof, like that. Or I could also have a different type of roof, and the software actually um, give us the ability to define any type of roofs. But this is more advanced. I can show it in another video. that concludes this step as well. Step 7. Define shades. We have horizontal, vertical, as neighbor buildings or balconies and wind walls, right? So again, by using the layer management tool, I just don't want to um, see the floors and roofs. Okay, I have a cleaner working drawing, and if I'm gonna go back to the ground floor, for horizontal shade, there is a slab here. I could use the rectangular command and just click a rectangle there. And then I can define it by clicking the horizontal shading seam slab icon, and I can select polyline, and it asks me for the slab elevation, which is 2.8, and the thickness is 0.2. So now just by double clicking it, it asks me to attach it or detach it. I accept the attach, and it asks me for selection of entities. I select the wall, right click, building block factor 100%, and 1 point of slab frame there. I also have a wing wall. I don't want to be hatched. The point is here, in this wall, and I have another one here, right. So now we have a neighbor building. Let's say it's somewhere here. To define it, I just click the vertical sensing definition. I select again the polyline and say that the building elevation is 0.1, which is the same elevation with the floor, and its height is 8 meters high. By double clicking it, I'm attaching it to this wall with 100 building blocking factor, and point is there. If I go one floor above, I don't have wing walls, I don't have horizontal uh, shades, but I do have again the neighbor building, which is I'm attaching it to this wall. Great. So now we have concluded the 3D model of the building with all the necessary data and info, and we're ready to export to the to XML files for the accurate sustainability software. So by using the AutoBLD accurate XML creation command, is that what gives us the XML files of the two dwellings. And if we'll take a look at our folder, we can see the Unit 1 Demo 01 XML file for the ground floor dwelling, and the Unit 2 Demo 01 XML file for the first floor dwelling. So if we open Accurate by using the command file import, in our folder, we can open the Unit 1 demo. And we have in project All the data fields are populated. Assessor details, client details, plan document. Constructions. Cavity brick, windows, door, floor, ceiling, internal wall, roof. Let's go to zones. In the ground floor, we have 3 zones, KLD, bed and bath. And let me do that. As we can see, floor, ceiling area, it's rightly populated, and also penetrations defined in the zones are given there. We have a downlight and an exhaust fan, bed, and bath. Shading. We have the overhang shading, and in vertical shadings we have the screens from the neighbor building. So if I go to elements and check KLD, for example, external wall, 90 degrees, I have the window, which is the number 11. It's aluminum BG clear. It's a sliding window, height, width, offset, and 55% openable. All data are here. Also, I have a wing wall with the projection and horizontal offset. Bed, bath. Internal walls, or let's see, all walls, internal and external. And as you can see, I have my windows there and my door there. Going to ventilation page, I have the footprint there, and here I defined my azimuth. So I just save, check, and simulate. And summary report. Fantastic. I'm gonna save that, and this will be saved in a profile, and then I'll do the same with unit 2. And here, for example, in my constructions, I do have a roof, and in my elements, I do have a roof. And if I go to external walls and select them all, I have my windows and my doors. And again, save and simulate. check our summary report. And that concludes my instructional video of FINE4Rate. Thank you very much for viewing this video. We at 4M believe that FINE4Rate is a very handy, convenient tool for the accurate assessor that not only enables him to save time and effort, but also by visualizing the 3D model of the building can keep him from making any data entry mistakes. For any further information about 4M or for FINE4Rate, please visit our website or contact us directly by phone or email. Thank you again very much.